Hey, what's up everybody? This tutorial is going to cover the matched pairs t-test. Alright, so I'm going to run through the four-step process and as I go through this example. Alright, so the data at right is a comparison of peak expiratory flow rate, PEFR, before and after a walk on a cold winter's day for a random sample of 9 asthmatics. Is there evidence to conclude that there is a difference in PEFR in asthmatics before and after the walk? Test at 0.05. Test at a 0.05 level of significance. All right, so what makes this a matched pairs t-test and not just a regular t-test for mu1 minus mu2 is that the data is paired. So we can see that each pair of data came from a subject. So person 1, person 2, all the way through person 9. So we basically have 2 pieces of data for each subject in this case. So again, that's what makes this a matched pairs t-test instead of just a regular t-test from mu1 minus mu2. All right. So what I usually do first on these is calculate what we call the D list or the difference list. So if I added another column here for D for difference, what I would do is I would just subtract. In this case, I'm going to do before minus after, since the after values seem smaller than the before values. So this would be a difference of 12. This would be a difference of 41. So I want to calculate those differences. So I'm going to do that on my calculator. So I'm going to go to a data set. So I already have this into my calculator. You can put this into L1 and L2 on your own. But then I'm going to create the difference list in L3. So for L3, I'm going to do L1 minus L2. And I'm going to hit enter. And this will give me those differences. So I can see my biggest difference looks to be 108. Smallest difference was -2. So there was one person where the after was actually larger than the before, but we can just kind of scroll through and take a look at those differences. Then what I'm going to do to get my sample statistics is I'm going to go and do 1var stats on L3, and I'm going to go to calculate. Okay, so I have X bar and S. So those are going to be the 2 that I use. So I'm going to go ahead and write those down back on this screen here. So the mean of that difference list gets called D bar. And in this case, D bar is 56.111. And the sample standard deviation of the D list is S sub D. And that was 34.174. My N value is 9, so N is 9, and I'm going to be using this alpha value of 0.05. All right, so now that I have kind of that initial work done, I can start my 4-step process. So I'm going to start with step 1. And step 1 is going to be as defining my parameters of interest. So I'm going to start with my parameter. So my parameter in a matched pairs t-test is mu sub D. And mu sub D is going to represent, in this case, the true mean difference in PEFR, so that was that flow rate for asthmatics before and after a cold walk. And specifically it was before minus after, so I'll put that in parentheses so it's clear. All right, so that's mu sub D, so that's defining my parameter of interest. Now what I want to do is write my hypotheses. So my hypotheses, again, are written in pairs with a null and an alternate. So my null hypothesis is going to be mu sub d, and our null hypotheses always get an equal sign. And what I'm going to do is I'm going to assume that mean difference is 0, so that I'm going to assume there's no difference between these two lists. So that's what I'm going to assume, and then what I'm trying to show is that there is a difference. So the problem statement doesn't ask me if there's a positive difference or a negative difference. It just asks me if there's a difference. So I'm going to make that alternate hypothesis a not equal to. So mu sub d is not equal to 0. So I'm really just trying to show that the two lists are different. All right, so now that I have that done, I'm going to move to step 2. Step 2, I'm going to test my conditions, or verify my conditions, and then name my procedure. All right, so my first condition is that I need a random sample. So in the problem statement, it does tell me that those 9 people were sampled randomly, so that's good. So I'm going to mark that random sample, check. Next thing I'm going to do is I need that normality condition to be met. So usually I look for a large enough sample. My sample is only 9, that's less than 30, so that's not sufficiently large. I don't know anything about the population, so what I'm going to have to do on this one is I'm going to make a box plot, and I'm going to analyze the box plot of the D list, so of those differences. So I'm going to go back to my calculator, and I'm going to make a box plot. So I'm going to go second y equals plot 1. The type of box plot is the one I have highlighted here, the one that shows outliers. And I'm going to change this to L3 because I want to actually do it for the differences. So you don't make it for both lists, you do a box plot just for that difference list. All right, and then we can hit zoom stat, and that's going to give us the pretty good picture of the box plot. Again, what I'm looking for is no outliers and hopefully some rough symmetry. So this does not show outliers, which is good. And it's pretty symmetric. The two whiskers are very close in length. The median's not quite in the middle of the box, but I would say certainly doesn't have a heavy skew. All right, so let's summarize that. So anytime you anytime you make a box plot on your calculator, you also want to draw it out. So I'm going to do that quick. So just make a quick scale. All right, and then I can go and look at my 5-number summary by hitting trace. So -2, 26.5, 63, 76, and 108. So then I can transfer those values here. And construct my box plot. All right, so that's the box plot. Then I also want to interpret it. So I will say that the box plot of the D list shows no outliers. Okay. And then I also want the condition about independence. So remember, you want your sample to be no more. Since we're sampling here without replacement, we want our sample to be no more than 10% of the population. So we only took a sample of size 9, so that's clearly going to be less than the population of asthmatics. So let's just write that. So we'll say the sample of 9 asthmatics is much lower than 10% of the population. All right, so that takes care of that condition. And we can now name our procedure. So we'll say the conditions for a paired, so you can say either matched pairs or just paired t-test are met. All right, so that is step 2. Step 3 now is where we actually perform the test. So what I'm going to do is make a picture. So remember, the 3 things you need is a picture, a test statistic, and your p-value. All right, so this axis is going to be the d-bar axis. This one will be the t-axis. So we're going to center this at 0. So our expected d-bar value is 0 if we assume the null hypothesis is true. The standard error is going to be that sample standard deviation over the square root of n. So 34.174 over the square root of 9, which is 11.391. So if we mark that on our picture, 11.39, 22.8 roughly, and negative 11.39, negative 22.8. All right, so remember that our d-bar value from that 1-bar stat screen was this 56.111. So really, if I'm trying to place that on this picture, it's going to be way over here. And I would then be shading to the right here. And I would do the same, because I'm doing a 2-tailed test, I'd do the same over here. Mark that and shade this tail. All right, so picture's not quite to scale, but what I want to do now is calculate a t-value for that d-bar value. So we take our d-bar value, subtract basically the null hypothesis, which is 0. This number will almost always be 0, and divide by that standard error, and that's going to give me a t of almost 5. So pretty far to the right. And then what I want to do now is calculate a p-value. So the p-value, because it's a 2-tailed test, I'm going to take 2 and multiply it by the number that I get from TCDF on the TI calculator. So what I'm going to put into TCDF is that t-value. I'm going to use 1E99 for a very large positive number. And then I have 8 degrees of freedom since I sampled 9 people. So if I put that into my calculator, I get 0.00058. And then multiply that number by 2. The p-value is about 0.0012. So pretty small p-value. And then remember, my alpha value was 0.05. So in step 4, I'm going to go ahead and do this. So then my p-value of 0.0012 is less than 0.05, which will allow me to reject the null. So then what I can say is that there is significant evidence to conclude that there is a difference in asthmatics before and after a cold walk. So that basically does give me evidence to conclude that there is a difference between these two values. All right, so that is your matched pairs t-test. So basically it ends up just being like a one sample test. The only difference is at the beginning you do have to calculate that D list and then calculate D bar and S sub D from that list. All right, so that is your matched pairs t-test. Thanks for watching.